All right, in this video we're going to do a supplemental problem, and this is a not in the homework set, but it's very like the assigned homework problem so that you can get an idea of how these should be answered. So I've copied down the whole question for you. This is number 6.5-7, and I've put in the data too. And instead of using up a whole lot of room on the paper, I did exactly what the book did and put this in columns. But I want to point out that this value here is the sum of all of the x's here. And so that value is the sum of x. Likewise, this is the sum of y, which were all of these. Maybe I should use a different color. Might be better. So sum of y. Now what I did was I put this into my calculator, or I could have put it into a spreadsheet, and I'm not going to ask you to show these calculations here. Well, I take that back. I'm not going to ask you to show these calculations here on a test. So you're welcome to use a calculator, or if it's online, the computer spreadsheet, what have you, as long as you're doing it yourself and not asking someone else, okay? So I've already put these in my calculator and hit the two variable stats. I have a TI 83 plus, so older calculator, but still very nice being able to enter the data into columns, X in one column, Y in the other, and then hit the two variable stats, and then I get these numbers. And so what we want to do first is calculate the least squares regression line. And so some of the questions in this textbook, I think they're written the way they are because this course will prepare you for actuarial exams. And so I believe that they are imitating how some of those questions are asked on the actual test. Okay, because we're going to see that something may seem a little confusing. It did to me anyway. Okay, so first is A, calculate the least squares regression line. So that is, we're trying to get this line with the estimate. So the first thing we need to do is find alpha hat and beta hat. Alpha hat is the easiest, using the estimate that we have shown, the regression line that we're using in this course. Oh, and I have this wrong too, don't I? Because that's not our regression line in this course. In this course, our regression line is alpha hat plus beta hat, x minus x bar. So I'm going to zoom in so we can see that a little bit better. So this, maybe I can just do this minus x bar. That is the regression line we've used in this course. Okay? So first thing is alpha hat. With this formulation, alpha hat is y bar. That's the sum of y over n, and the sum of y is 121, and n is 12, and that gives us 10.083. Oh, have that wrong. Forgot a decimal place. 0.8333. Okay, so I'm going to round this to 3 decimal places. So I'm going to say that is approximately 10.083. Now the reason that I'm rounding to more decimal places than I should only round to 1 decimal place because our data has 0. I'm rounding to more decimal places simply because it will give us a better estimate in the end, a more precise estimate. So we can round the final value y hat. So usually we'll use the exact values in the computer for these estimates. That way, what we're rounding at the end is the answer, not the slope or intercept in between. So I hope that makes sense to you. But here is alpha hat, and beta hat is given by this formula. Remember that this is a calculation formula. What the computer uses much easier than using the definition of the sum of squares of xy and the sum of squares of x. So sum of xy is 1294 minus, and so sum of x was 110, sum of y is 121, and then I can divide by 12. Now I can do this in the calculator. This 12 divided by 12 is only going to divide these two numbers because this minus sign separates it. If you wanted to divide the whole numerator, you'd have to use another parenthesis. Okay? So let me get rid of the scribbling. There we go. Back to green for now. And then this will be over. Sum of x squared is 1234 minus 110, which is the sum of x, 110, not 100, divided by n, which is 12. And this gives us, plug this into the calculator, 1294 minus 110 times 121 divided by 12 gives me 184.83, and this is repeating. And then, so when I plug this into the calculator, I'm going to use a whole bunch of threes up there to be as precise as possible. Okay, and then the numerator is 1, 2, 3, 4 minus 110 divided by 12. This is squared, 110 squared, so let's not forget the square, divided by 12. And that gives me 225.6666. It keeps going. Okay, so in my calculator, I'm going to use the x to the negative 1 button, and that will put this 225.2 on the bottom. Okay, and then times the number on the top, 184.33333333333 equals. And so, get a number that's a little different than what I thought I was going to get. Let me check this to make sure that everything is right. So we have 110, 121, and sum of x squared, sum of xy is 1294, sum of x squared is 1234, sum of x is 110. Yes, okay, so let's make sure that 1294 minus 110 times 121 divided by 12. Yes, divided by, now I can use parentheses and do this all in one step, but I don't like to do this very often. So divide by parentheses 1234 minus 110 squared divided by 12, close parenthesis. Yep, okay, so I must have done something wrong because I'm getting the right number now, which is 81904546529. Okay, so let me do the new denominator again. 1234 minus 110 squared divided by 12, 225 and 2/3, and then the numerator 1294 minus 110 times 121 divided by 12. Yep, 184. So divided by 225.6 equals, yep, 819. I must have hit the wrong button. Okay, so, and I'm going to round that to 0.819. So now I have my regression line is y hat equals alpha hat, which is 10.083 plus 0.819 x minus x bar. And there is my regression line. Okay, now, in part A here, we have found the point estimate of alpha and the point estimate of beta. Those are alpha hat and beta hat. So when we get to part C, we've already done it, so we don't need to do it again. Okay? So part B is plot the points and the least squares line on the same graph. And so I've put the title here, tar and carbon monoxide in 100 millimeter filtered menthol cigarettes, okay, from different brands. So on my x-axis is tar, on my y-axis is CO, and I've already plotted the points, so we have those. Now, I have to plot this line, y hat equals 10.083 plus 0.819 x minus x bar. And I can actually plug in, I guess I should plug in for x bar, 10.083 plus 0.819 x minus. Now, x bar, the way the book does it is they leave it in exact values. So they like to leave the fraction. So x bar be 110 over 12. Yeah, 110 over 12. Okay? And so I guess this would be the line that we should, not guess, that's the line that we should report. Okay. So with x bar plugged in. So now we've got down here, this is 110 over 12. Let me zoom back in. Okay, so my lowest value of x up in the data is 3. Whoops. Okay, so and my largest value is 17. So those are the values I'm going to plug into my line. I should never predict beyond the values of x that are observed in the data. Otherwise, you don't know, the line may not even be defined over there or outside that range, or it might have a different relationship, or we may be zoomed in on the line so much that we don't know that it's really curved instead of straight. And so if you go too far beyond the limits, you run into that curve and have larger errors in your results. So it's never a good idea to go beyond the observed values of x to predict. So 3 and 17. So 3 and 17. There we go. And so we'll call this 1, this 2, so 1, when I plug in 10.083 plus 0.819 times parentheses 3 minus 110 divided by 12 equals, gives me a 5.0325. Now, all right, so let me try it again. I've got 10.083 plus 0.819 times parenthesis 3 minus 110 divided by 12, close parenthesis. Yes, good. Now the next one, 10.083 plus 0.819 times parenthesis 17 minus 110 divided by 12, close parenthesis, gives me 16.4985. So this is close enough to 5, and this is maybe 16.5. So I'm going to do my best to plot these. Okay. So I have a ruler here I'm using on my iPad. So 3, that's my lowest value here. And when I plugged it in, I got 5. So the actual value I had was 4. So 5 will be about there. And then for x equals 17 here, you can't see my ruler, I realize now, 16.5. So this is at 17, and 16.5 would be maybe here, and that was at 5. Yep, okay, so here's my line, here's my point, and now I'm going to draw a line in between them. It's a straight line, so I don't need any other points. Okay, and so I'm going to label this now. I'm going to label it as y hat equals 10.083 plus 0.819 x minus 110 over 12. Okay, so that is part B. That's all you have to do for part B. Now, part C can be a little confusing because it says find point estimates for alpha, beta, and sigma squared. From part A, we have y bar equals 10.083. And from part A, so this is alpha hat, and from part A, we have that beta hat equals 0.819. So we're done with that part. Now we have to do sigma squared hat. Okay? So this is the formula from your book. I told you in the homework to use this formula, so this is the one that we're talking about. So I'm just going to fill it in. So 1 over 12 and then a bracket around everything else. Sum of yi squared is 1411, I believe. Yes, 1411. Minus 1 over 12 times sum of y, which was 121, quantity squared, minus 0.819, which is beta hat, sum of x times y, I believe that was 1234, but I'll verify. Yeah, no, it's 1294. Glad I verified. 1294. And then plus beta hat, which is 0.819, and then 1 over 12, 1 over n, and then 110 times 121. And so I get, so I'm going to do what's inside the bracket first, and then I'll divide that by 12. So I'm not going to do this first part to begin with. I'll just say 1 over 12, and then I'm going to do 1411 minus 121 squared divided by 12 minus 0.819 times 1294 plus 0.819 times 110 times 121 divided by 12. And that gives me 39.5381, and then 6 is repeating. And so divide that by 12, and I get 3.29484722, etc. Okay? Which is approximately 3.3. And now I'm going to... So this is sigma hat squared for everything. So what I'm going to do is, never mind. That's I'd have to do a lot more work on my calculator to verify that. Okay, so that is the example here for section 6.5. And so I hope this helps you either do your homework or confirm that you've done your homework correctly. So, take care of yourself. We'll see you next time.